This is Mr. Beck Does Your Homework, AP Physics, Homework 3.2. Question number 1. It says a 25 kilogram chair initially at rest on a horizontal floor, so here's my chair at rest on a floor, requires a 368 Newton horizontal force to set it in motion. So as soon as I push with 386 newtons, that chair will start moving. Once the chair is in motion, a 340 Newton horizontal force keeps it moving at a constant velocity. Well, that's going to be for my next part of the question. What is the coefficient of static friction between the chair and the floor? So I'm looking for the coefficient of static friction, and I know that that is going to be the force of friction divided by the normal force. Well, if it takes 368 newtons to start it moving, my other forces there are going to be a normal force, a force of friction, and a gravity force. Now, since this is to start it moving, I know that 386 newtons must be what force of friction is just when it starts moving. So that's 386 newtons of friction as well. Now, how do I get my normal force from this? Well, I know that since this thing isn't accelerating up and down, I know that normal force and gravity are going to equal each other. So my gravity is going to be my mass times the acceleration of gravity, is going to be 25 kilograms times 9.81 in this case. So that's going to be 240 something or other. And that force of gravity is going to be the same as the normal force. So that force normal is going to be the same as the force of gravity. Okay, so my force normal in this case equals my force of gravity, because those are my only up and down forces. So now my coefficient of static friction is going to be my force of friction of 386 newtons divided by my normal force, which is whatever this answer was here. It might be greater than 1 in this case. It happens a couple times on several people's homeworks. It doesn't look like it's happening on mine, but if you get a mu greater than 1, don't worry about it. Oh yeah, there it is. Yeah, that's going to be greater than 1. Normally the coefficient of static and kinetic friction is less than 1, but just the way they pick the numbers. So that will give you the coefficient of static friction for this problem. Question number 2 says, what is the coefficient of kinetic friction between the chair and the floor? So now, once the chair is in motion, 340 newtons keeps it moving at a constant velocity. Now, constant velocity is our magic word there. That means that the forces are balanced. So I will have a gravitational force, I will have a push force, I will have a normal force, and I will have a frictional force. Since forces are balanced and all of this is x world, y world, I know that my force of gravity is going to be the same magnitude as the normal force, equal and opposite. I know that my force of push is going to equal my force of friction. So in this case, my force of gravity is going to be the same as I had before, this 25 times 9.81. So my mu kinetic is going to be my new force of friction, which is now going to be, for me, 340 over the same normal force. And that's going to give me my new coefficient of kinetic friction to keep it moving.